Hey everyone, how's it going? This is day 27 of Project 365. I'm going to set a timer now, so let's say maybe 5 minutes. Okay, in less than 5 minutes, I'm going to teach you what I've scribbled here. Okay, let's start from this box over here. So this box over here, right, just above this box, there's a bunch of air molecules just hovering over the box. And those air molecules actually push down or exert a force on this box, and that force is called pressure. Just like how there's some air molecules exerting some pressure on this surface area, we can look at the earth over here. So these are all a bunch of air molecules that put some pressure on the earth's surface. How much pressure exactly, you might ask? About 100,000 Newton force. Just for maths, easier maths purposes, we're going to change that to 1,000 hectopascals. Who the heck is hectopascals? So pascals is basically a smart French dude who used to study pressure, so hence we named it after him. Alright, so this is what amount of force exerted on the earth. For standard pressure or international standard atmospheric condition says it's about 113 hectopascals above mean sea level. So above mean sea level everywhere around this earth, this should be the standard pressure, just for mathematical reasons. This might change, but this is just the standard conditions. Just like how we have a standard pressure, we also have standard temperature, which is about 15 degrees Celsius. So international standard atmospheric temperature above mean sea level is about 15 degrees over here. Let's see how much time we got. We have about 3 minutes. And let's look at Q and H. What is Q and H meaning? Query, nautical, height. So basically that's the pressure we are feeling right now just above Sydney Airport. It's about 10-20 hectopascals. That's today. So YSSY is the ICAO code for Sydney International or Sydney Kingsport Airport, and the elevation is about 21 feet above the mean sea level. So these are all the basic criteria that we know based on the resources available. So now we're going to use this, plug it into these formulas to find out what our pressure height is. What is pressure height? Pressure height is basically the height at which the aircraft feels it's flying. So basically that's the formula to find the pressure height. So if we key in these numbers over here, the aircraft is actually feeling like it's flying 189 feet below the sea level. That's why we have a negative number over here. Okay, 2 minutes. So similarly, the icy temperature, because we are only 21 feet, we're not feet in thousands. So basically this is 0. So we have 15 degrees. And what's ISO deviation? ISO deviation is basically the outside air temperature. What's the temperature right now? That's about 16 degrees. And what's the standard temperature? Which is about 15 degrees. What's the difference? That's 1 degrees. So we're going to key in these numbers into density height formula, which is over here. Okay, what's density height? Density height is related to the performance of the aircraft. So pressure height is how high the aircraft is feeling, and performance is what's the performance we're getting based on the density. So that's ISO deviation times 120 plus the pressure height, which is 120 minus 189. So we are getting a performance of about negative 69 feet. If we are below 69 feet, below the mean sea level, we will get a density height of this. That's for the performance. That's how poorly the aircraft is performing. It's similar to 69 feet below the sea level. Let's see how much time we have left. So we have about 30 seconds left in this video. Make sure you like, subscribe, and comment. If you have any questions, put it in the comment section below. That's all for today. Basically, it's just me explaining what I learned in today's class.